In this video, we're going to take a look at maximizing revenue, minimizing cost, average cost, and maximizing profit, all given a revenue and cost function. First, this is what the problem looks like. There's a lot of information here. When you walk through any kind of problem like this, the first thing you're going to do is put your pencil down and then read through the entire problem. Try to put yourself in the place so that you understand what it's talking to. The next thing you're going to do is, does it seem like something you've seen before? Have you seen it similar? Do you know what they're asking you to find? And then lastly, the third time through, pick up your pencil, write down what you are trying to find, write down any information they give you, variables, equations, and things, and then get started on the problem. One of the biggest mistakes when looking at this kind of problem is to just start flying into it right away, not really sure where you're headed. So here's the problem again. Just pause the video if you would, please. Read through it 3 times. Once to put yourself in the neighborhood. Second, to figure out what it's asking you to find. Have you done it before? Things seem similar. Then pick up your pencil and write down important information. Go ahead and pause. Okay, so they've given us revenue and cost. We're talking about refrigerators, where we have revenue in dollars from selling X numbers of refrigerators. And the first thing we want to do is maximize revenue and find out how many refrigerators must we sell. So they gave us the number of refrigerators, they gave us revenue, they gave us cost. They didn't give us profit, and they didn't give us average cost either. Let's go find those equations and then gather all of our equations together. So to find the profit, remember it's revenue minus cost. Here's the revenue portion. Minus cost, don't forget to go ahead and distribute that negative sign to both of these pieces. Then when you collect like terms, you get this as a profit function. When you're looking at average cost, it's the cost function that they gave you divided by how many. It's like taking the average cost, what are the total dollars spent, then divided by the quantity. You get this to start with, but we can pull those fractions apart. If you remember, so recall, if you have 1/5 plus 3/5, you get 4/5. You can go this way or you could go this way. We're going the opposite direction and pulling the fraction apart from this step down to here. We do that because now this guy's really to the first. We can put him to the negative exponent. We know we're going to have to do a derivative, so that's a power rule. And then here, this x divides out with one of those to give you 0.6x. Now we have all of our equations. Here they are, all ready to go. And let's answer the first question. How many refrigerators must be sold to maximize the revenue? Well, we need the revenue function, and we're going to take the derivative, find the critical values, and it's an open interval, so if we only have one critical value, we can use concavity to answer the question. So let's do that. First derivative with respect to the revenue, 280 minus 0.8x, set it equal to 0. Now we're looking for critical values, right? So we get, this kind of comes along for the ride. Add 0.8x to both sides. Divide by that 0.8, and you get 350. Well, that's exactly one critical value. So that means we can use concavity and the second derivative to figure out where this maximum is. And so take the second derivative with respect to x of revenue. When you do that, you get negative 0.8. That's less than 0 for all x, and that's for all x, which are real numbers. And that means then, less than 0, it's concave down, and we have a max at our critical value, 350. That means then that we need to sell 350 refrigerators or units to maximize the revenue. One part done. What is the maximum revenue? Well, we know that occurs at x is 350. How do we find revenue? We substitute our value in. So take the revenue function, this guy here, simplified, and substitute that in. 280 times 350 minus 0.4 times 350 squared, and that's going to give you 49,000. So let's give our answer the maximum revenue of 49,000 occurs when 350 units are sold. And another one down. Next question. What is the profit when this number is sold? So we're looking for profit. But it's when this number is sold. So can't we inside here put that value, the 350? But do we have a profit function? We do. We found profit. So let's find P of 350 equals 280. We're substituting in for every x minus 350 squared minus 5,000. Gives us negative 29,500. And what some people say at this point is, oh no, can we have a negative number? And the answer is yes. They're just losing money. So there is a loss of 29,500 when 350 units are sold. So we've got to figure out, how did costs get so out of control? You can't just maximize revenue and expect profit to follow, because costs could be ballooning out at an outrageous amount. So let's go ahead and turn our thoughts now towards average cost. How many refrigerators must be produced to minimize the average cost? Here's our average cost. We want to minimize that, and so that means we're going to need to take the derivative. We're going to need to find critical values. If there is just one, then we can use the second derivative of the average cost to show where we have a minimum, and then pull that number. So let's go ahead and find the derivative first. And average cost, remember, is here. Bring the negative 1 down, so you get negative 5,000 x to the negative 2 plus 0.6, just the 0.6. And we're looking for critical values, so we're going to set it equal to 0. Go ahead and write that as a fraction, because now we can add it to both sides and then cross multiply to get, now some people take 2 steps to do this. They'll write 0.6x squared equals 5,000, then divide by 0.6. Like that. But we got an x squared. We're going to have to take the square root of both sides. And it's plus or minus. So that gives us x is equal to the positive square root of 5,000 divided by 0.6, and scoot this up a little bit, sorry, minus the square root of 5,000 over 0.6. But I'd like to make the argument that we can't have a negative quantity, so we're going to throw out that negative piece and only keep this as our quantity. Now don't round yet, just leave him the way he is, because we're going to need to actually do some work with that. Let's approximate it. I know you're dying to approximate it. Let's approximate it about that, which is about 91. There is exactly one critical value, so we're going to use the second derivative. And when we take the second derivative of this guy, we get positive 10,000 x to the negative 3, which is this. Evaluate it at our critical value, and our critical value is about 91. And so that makes it about 0, 1, 3, 2. That's greater than 0, which means you have a min at your 91. Our final answer then is that we want to sell about, remember we average, we didn't take our entire value here, so we're approximating it at 91. So it's about 91 to minimize average cost. And so that answers that question. Now they want to know, what is the average cost? Average cost is here. We found that X is about 91. Sorry, I'll use little tildes there because we are approximating. About 91. So substitute that in to the average cost. So that's about 5,000 divided by 91 plus 0.6 times 91, which is about 109.55. That means the minimum average cost is about 109.55 each. What's our next question? What is the profit when this number is sold? So this number is sold. We're still at about tildes 91. And so go ahead and find the profit. Remember, we found this equation at the beginning because we knew we were going to need profit and average cost, so we don't have to go find it again now. 280 times 91 minus 91 squared minus 5,000 is 12,199. So that is telling us the profit is $12,199 when 91 units are sold. Well, now we know what the average cost is, the minimum average cost is. We knew what we needed to maximize revenue, but that was making us lose money. So the bottom line is, how do we maximize profit? So we're taking this profit function and trying to maximize it. How are we going to do that? We're going to take the derivative. We're going to find the critical values. If there exists exactly one, then we're going to use the second derivative and concavity to show that is a maximum. So let's go ahead and find that first derivative of the profit. And when we do that, we get 280 minus 2x. We're looking for critical values now. Set it equal to 0. Add 2x. Divide by 2. Yay, there is one critical value. So that means we're going to use the second derivative of the profit to show that we do indeed have a maximum. So take the second derivative of the profit. You get -2. That's less than 0 for all real numbers, which means that it's concave down and we have a max at our critical value, which is 140. We can write our solution. We want to sell 140 units to maximize profit. One last question. What is the maximum profit? Remember, our critical value was 140. We want to know the profit at 140, so go ahead and substitute that in using the profit function. 280 times 140 minus 140 squared minus 5,000 That's going to get us 14,600. And our final answer then is a maximum profit of $14,600 occurs when 140 units are sold. Remember, include all the information you can here in your final answer. And that's it. Hope you're having an amazing day.